Okie doke. How's it going, everybody? We are already at day 10, believe it or not, in Advent of Code. For those of you that haven't been following along, I'm doing this in Rust. It's not my language of expertise, but that's just part of the fun. Anyhow, let's try and solve this problem. Today's problem is called syntax scoring. You ask the submarine to determine the best route out of the deep sea cave, but it only replies syntax error and navigation subsystem online, all of them. All of them? The damage is worse than you thought. You brought up a copy of the navigation system, your puzzle input. The navigation subsystem syntax is made of several lines containing chunks. There are one or more chunks on each line, and chunks contain zero or more other chunks. Oh, great. So we've got a parsing problem here. Adjacent chunks are not separated by any delimiter. If one chunk stops, the next chunk, if any, can immediately start. Every chunk must open and close with one of four legal pairs of matching characters. If a chunk opens with parenthesis, it must close with parenthesis. If a chunk opens with square bracket, it must close with square bracket. If a chunk curly bracket, and then angle bracket. So parenthesis is a legal chunk that contains no other chunks, as is open square bracket, close square bracket. More complex but valid chunks include blah, blah, blah. Lots of examples here. Some lines are incomplete, but others are corrupted. Find and discard the corrupted lines first. A corrupted line is where a chunk closes with the wrong character. That is, where the characters it opens and closes do not form one of the four legal pairs listed above. It has some examples of corrupted chunks. Such a chunk can appear anywhere within a line, and its presence causes the whole line to be considered corrupted. For example, consider the following navigation subsystem. Okay, it's a bunch of this stuff. Some of the lines aren't corrupted, just incomplete. You can ignore these lines for now. The remaining 5 lines are corrupted. Expected a closing square bracket, but found a closing curly brace instead. Expected a closing square bracket, but found a closing parenthesis instead. Blah, 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 blah. Stop at the first incorrect closing character on each corrupted line. Did you know that the syntax checkers actually have contests to see who can get the high score for syntax errors in a file? It's true. To calculate the syntax error score for a line, take the first illegal character on the line and look it up on the following table. Close parentheses is 3 points, close square bracket is 57 points, close curly bracket is 1,197 points, and a close angle bracket is 25,137 points. In the above example, an illegal parenthesis was found twice. Blah, blah, blah. This is just a math example. Find the first illegal character in each corrupted line of the navigation subsystem. What is the total syntax error score for those errors? To begin, get your puzzle input. All right, let's get the puzzle input here. Where is... Oh, you know what? It's not on a different desktop. I keep moving to different desktops when I have everything available on this desktop. All right, so here's our input. We pasted it in there. I guess we just need to parse this and just read it into characters. I think the parsing for today's problem isn't going to be too bad. And we're just trying to find illegal characters. What that means is that we're usually when you do kind of like brace matching problems, what you're doing is just keeping a stack of braces that are open, and essentially the next closing brace that you find needs to match the opening brace at the top of the stack. Right? And we do that for each line. So that shouldn't be too bad. So what we're going to do is we might be able to just like iterate over every line, right? We can just do get input dot lines. And then I guess we're doing score. Right, so we can even do a fold here where we're just accumulating the score. And we'll call this the total. And we've got the line. And so for each line, we are going to iterate over the characters and build up a stack. Right? So we can do for C in line.chars. It's an iterator there. And let's just have our our brace stack. Let's just make that a vector, right? And this is actually a vector of characters. And if we get we're basically going to match on this character. And we're going to have different behaviors based on this character. The default is going to be, I think, a panic, right? If we get this far, if we get here, we've got a character we don't recognize, right? I think we can do this way. Okay, now we just need to match each character. So if we get an open parenthesis, we're going to push onto the stack. Actually, we're going to basically push on for any open character, right? Open square bracket, open curly bracket, and open angle bracket. And then for the close brackets, the corresponding close brackets, we are going to want to make sure that the last thing that we pushed corresponds to that, right? So maybe we don't want to use the same code for all of these. What we can say is that if stack, how do we get the last item in a vector? Is there an easy way to do that in Rust? Last element of vector. There's probably just going to do a length -1. There is a .last function. And the return value of this is probably an option. Yeah, if we just unwrap it. Well, we shouldn't unwrap because the stack might be empty, right? So maybe what I had there before is going to be actually okay, because we want to actually have, like, if the stack is empty, if the stack is equal to 0, if it's empty, then we've actually found our first corrupt character, right? And so what we're doing now is we're going to return the total plus the score, right? So let's actually make a little function. I'm actually kind of wondering if it might be not the worst thing in the world to do a little bit of parsing here, just so I can make sure. I just don't want to have to write, like, I'm going to be doing a lot of matching on things, and I just want to make sure that I have the right things. Well, I don't know. That's just going to be fuzzy. I'm sort of maybe thinking too far ahead for myself here, but we do want to be able to get the score for certain characters, right? Let's see. Score of char C, and this is just going to be some value. We're going to match on C, and the scores are this. And so let's go ahead and, for all of these lines, we're just going to add a that should be it. It's not formatting because I don't think char C is valid Rust. C char there. I also expected this to maybe add a tab here. I think maybe just because my code isn't parsing correctly. Let's do score of C. Can I add I64 to well, the result down here is just going to be total. Okay, so if we pushed onto it, I don't like fold here. Fold here is just being a little bit too clever. I think maybe I'm just going to do a regular old for loop. We actually still want the stack for this particular line. Okay, stack is there. The total, we're increasing there. We're adding the score here. We're just not return. When we return here, what I think we actually want to do is we want to go to the next line. So I think we can do next line. And we can do continue next line. And then this is total plus equals score. We know it's corrupt if the stack is empty. Otherwise, if the end of the stack dot last dot unwrap, now we can unwrap it, right? We got a match on this. Well, what we really want is we just want to make sure that if C, we want to know what the corresponding closing brace is, right? So let's get closing brace. We're just going to have a function that's very similar to this. That's just going to map the opening braces to the closing braces. Kind of makes me wonder if the ASCII integer values for the closing braces and opening braces have a particular relationship to each other. Like, is it just +1 on the ASCII table? Like, the opening brace, opening angle bracket is 2 before the closing angle bracket. Same with square bracket, same with curly brace. Parenthesis is the wrench there. It's kind of weird. I wonder what their philosophy was in designing these ASCII symbol tables. Why not put the angle brackets next to each other? Pretty unusual if you ask me, but there's probably lots of history and lots of stories about how they designed this particular symbol table. At any rate, let's go ahead and plow ahead. So this is not score. This is basically closing brace for that character. And we'll return char here. So if the stack length is 0, then we have corruption. Also, we have a corruption if the end of the stack, last, to unwrap, if C is equal to the closing brace of the last thing in the stack, then what we can actually do is pop something off the stack, right? Stack.pop. And then we continue. Otherwise, if we've gotten this far, maybe what I would like to do is go, if it's not equal to this, total plus equals score C, and maybe we can even actually combine this case here, right? So our corruption case, our corrupt line cases are either we've seen a closing brace even though the stack size is 0, or that we've seen a closing brace and it doesn't match the last opening brace in our stack. And in that case, we're going to add to the score and just go to the next line. Otherwise, we need to pop the closing brace off the stack, which we can just do like this. Or rather, we pop the last opening brace off the stack. And then we can print the total. Just have to make sure our references and dereferences line up. Looks like it compiles. So let's go ahead and see what happens when we actually try to run this thing. 838,470. Not the right answer. It's too high. All right, let's try it with our sample input. Got those 10 lines. That's 80,370. Okay, yeah, so it's way too high. If we're getting up to 80,000, does that mean that we're just like running into the close angle bracket too frequently? So to debug, why don't we actually just print out each line as we visit it? Or we can print out each line here. The bad character will print out as well. So we print out the whole line and we print out the bad character. And we can take a look. So I'm going to go ahead and copy this into a new text file, and let's compare it to the analysis that's providing here. This is the right answer, or the right analysis. So we're using this to find the error in our logic. So I think what this is saying is that essentially in our first line here, our first line, we shouldn't have found a bad character. It says it's the closing brace. Right. Now, I'd be interested in knowing which closing brace we're actually breaking on. It could be this first one or it could be the second one, but I'm going to wager it's the first one. Oh, you know what it is? I'm pushing parentheses the entire time. Let's try this one more time. Silly mistake. 26,397. Okay, that looks correct. So that means probably our code was correct aside from that little bug. I'm going to go ahead and remove my debug printing here. We're going to run again with the actual input. 370,000, so that is lower. Let's go ahead and plug it in. Okay, great. We got the right answer. So aside from a silly little mistake, we got the logic of the code correct the first time. All right, so now discard the corrupted lines. The remaining lines are incomplete. Incomplete lines don't have any incorrect characters. Instead, they're missing some closing characters at the end of the line. To repair the navigation subsystem, you just need to figure out the sequence of closing characters that complete all open chunks in the line. You can only use closing characters that are listed here, and you must add them in the correct order so that only legal pairs are formed and all chunks end up closed. In the example above, there are 5 incomplete lines. Okay. Did you know that autocomplete tools also have contests? It's true. The score is determined by considering the completion string character by character. Start with the total score of 0. Then for each character, multiply the total score by 5. And then increase the total score by the point value given for the character in the following table. Okay, and there's a scoring table right there. So the last completion string above, blah, 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 is scored as follows. Start with the total score of 0, multiply the total score by 5 to get 0, and then add the value of closing square bracket 2 to get a new total score of 2, and then and so on and so forth. And then you add together each line's score. Autocomplete tools are an odd bunch. The winner is found by sorting all of the scores and then taking the middle score. There will always be an odd number of scores to consider. In this example, the middle score is 288,957 because there are the same number of scores smaller and larger than it. Find the completion string for each incomplete line, score the completion strings, and then sort the scores. What is the middle score? This whole middle score thing is a little bit of like a weird curveball. I'm actually not 100% sure why they threw this in there. The actual problem of doing the auto-completion is not that bad because I think what we're really looking for is essentially just, we're keeping a stack of unclosed brackets in order, and we basically just need to reverse that ordering and then find the corresponding closing bracket, which we just wrote a function for, right? Okay, so let's actually build off of this first part of the day's project. I'm going to go ahead and just commit to Git what we currently have and then move on. All right, let's go ahead and make a copy of part 1 into part 2, and we'll go ahead and get part 2 ready. All right, give the IDE a quick reload just so it recognizes the new folder, and we should be in business. All right, so our score algorithm is going to change just a little bit. It's 1, 2, 3, 4, counting up from here. So I'm going to go 1, 2, 3, 4. And not only are the values going to change, the way that we use the score function is going to change as well. Okay, so what this is doing here is keeping track of the old score, but I think what we're just trying to do is just skip the corrupt lines, right? So all we need to do is just leave this continue statement so that whatever code goes down here for the new stuff isn't processed for lines that are corrupt. So this is basically corrupt line detection. And in fact, actually, I think this is looking pretty reasonable. All right, so once we've gotten through here, we've processed all the characters in the line, and we haven't detected a corruption in that line. So now we just need to reverse the stack and then calculate the score. And we just need to keep a vector of those scores. Okay, and the way that we do that is we want to take the stack and we want to reverse it. And then what we're going to do is keep a score, which starts at 0. And then for each character in the stack, we are going to, first of all, our score is equal to 5 times its previous value, right? And then we are going to add to it the score of the closing bracket. I mean, we actually don't even need this closing brace thing because we could just convert this score into the opening brace version. Well, we do need the closing brace because of this thing here. So maybe we'll just leave this just so it more literally represents what the problem is describing, which is this chunk right here. So we're going to get, I'm using the same variable name. So let's call this the line score. And this is going to be the closing brace of our current character. And then our scores, we're going to push onto the end of this. And the ordering doesn't matter because we need to sort them by value. And then finally, at the end of this, we're going to sort these scores. And then we're going to find the middle value, which is the length divided by 2 plus 1, because we're basically asserting that we're assuming that the number of items in this scores vector is odd. When we do an integer division of an odd number, it's the division rounded down, so we have to add 1 to get the middle one. So we'll do scores.length divided by 2, and let's add 1 to that. That'll give us the middle score. So let's try running it and see what happens. That looks really quite high, but we are multiplying by 5 every single time, so let's just see what happens if we just plug it in. Not really optimistic that this will work, but let's see. Yeah, it's too high. So once again, we are going to use the sample input and just see where it takes us. And on top of that, we know that that's probably going to be incorrect, so I'm probably going to like print out the closing braces that we want as well. So what's the right way to do that? It'd be stack.iterator. And we want to basically join these. We want to collect these into a string. Unused return value. Okay, so it knows how to do it. So what we want to do is just print it, right? So let's debug print the line that we're currently on, and then here we go. Borrow of moved value. Where did we move it? Oh, we moved it here. So let's do an iterator here. And that should be okay. Closing brace. Dereference that. And I think that is going to be it. This might be a good example of where we could use a fold, right? Let's try that. Stack.iter.fold. Starts at 0. Our accumulation is here. And our character that we're currently on, which is the opening bracket, is there. And it's going to equal the accumulation times 5 plus the score of the closing brace. Dereferenced. And now this doesn't have to be mutable anymore. Why don't we also go ahead and just print out the line score here just to make sure that we're calculating it correctly. I'm just very curious what this will end up looking like. I kind of wish this was printed all on one line, so I think what we're going to do is we're going to do a println here. And just separate these by pipes. Is that going to be visually distinctive enough? Maybe we can do dots. I say visually distinctive because we're going to see a bunch of like open and close braces, and we want to just have a character, a delimiter that like is really easy to visualize and see. So let's try that. How does this look? That's not too bad, I would say. And this is our correction here. Let's actually, in order for us to match this, what we want to do here is we want to map over these characters and actually return the closing brace of the character, which prints out this way. So this is what we got, and this is what we want. That looks like what we expected. This 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 looks like what we expected. And then what scores are they telling us to get to? The scores they want look like this: 288,957, 5,566, 148,781, 995,444, 294. Okay, and then what's the middle of those? 288,957. Okay, so it looks like the way that I'm calculating the middle score might be the issue here. A length divided by 2. Let's say you had 3 elements. The length divided by 2 is 1. It's element 1. And then 1 plus 1 is 2. So I think this add 1 is not correct. We're off by 1 here. So if I ran this again with sample input, it's 288,957, which is what we were expecting. All right. So let's try again with our actual input, or the input that the problem is giving me. And this time I get this number. I have no idea whether it's lower or higher than what we got before, but we're just going to go for it. And we got the right answer. Great. So it looks like we had all the logic mostly correct. The only issue is just that I was off by 1 when I was looking for the middle score. So the weird curveball that I was sort of complaining about, this sort of extra little complexity, I think maybe is a speed bump to just like make sure that people that are really going fast in the competition have to pay attention to one more thing that can trip them up. It's not really elemental to the problem. I think the really key insight in doing this particular problem is just knowing how to just tracking this stack of open braces and then making sure that you're popping off it as you're seeing the closed braces. All right, well, that's it for day 10. I'd say this one we were lucky. It was relatively straightforward. It didn't take us too long. We'll see what happens tomorrow. Okay, take care, everybody.